Okay. Welcome everyone to today's class. Welcome. Welcome to everyone on TikTok and also to those on YouTube. We'll be starting the class in about 1 minute time. Okay. So let me just connect my students in my WhatsApp group to the class, and then we'll be on our way. Okay. So today's topic is binomial theorem. So that's what we are looking at today. Just give me a minute. Okay, I think we're set. Okay, so the topic today is binomial theorem. Okay, so for us to understand the topic, first we need to know what a binomial is. What is a binomial? A binomial is a polynomial with two terms. A binomial is a polynomial with two terms. Is a binomial is a polynomial that has two terms. So looking at this, we need to remind ourselves what a polynomial is. Okay? So polynomial means something that has many sides. So polynomial is an algebra that has many sides. So we have different types of polynomial. We have monomials, we have binomials, and we have trinomials. We also have other polynomials that have 4 sides, 5 sides, and so on. Okay, but a binomial is a polynomial that has two terms. So if I have a polynomial in this form, let's say I have something like this, 4x. 4x is a polynomial, but it only has one term, or you can say it only has one part, just 4x. But on the other hand, if I have 4 plus x, now this plus is separating these two parts. So this is one term, this is another term. So this polynomial has two terms. The first term is 4, the second term is x. So we can simply say that this polynomial is a binomial because it has two terms. However, 4x is not a binomial. It is a monomial. That means it has only one term. If I also have 3 plus a plus 6, 3 plus a plus 6, this is not a binomial because it has 3 terms. Term 1, term 2, and term 3. So once they are separated by either a plus or a minus, then these are different terms. So this is the only one that qualifies as a binomial. Okay? So a binomial is a polynomial that has two terms. So that's the first thing we need to understand. Okay? So binomial theorem is used to expand a binomial. Okay, so when you have a binomial that is multiplying itself, then you can use binomial theorem to expand it easily. Okay, so if we have, for example, if we have 2, or let's say x plus 2, x plus 2 as we have it here is a binomial, right? Hope you guys can hear me clearly. Those of you on TikTok, hope you guys can hear me clearly. Let me see. Those on TikTok, hope you guys can hear me clearly. Please give me a minute, let me confirm. So x plus 2 is a binomial. But what if we have a situation where x is multiplying itself, which is x squared? We know that x squared is the same thing as, sorry, x plus 2 squared. This is x plus 2 multiplied by x plus 2, right? So if you are told to expand this, that means this is going to multiply this. And we know what the answer will be. X multiplied by x is equal to x squared. X multiplied by 2 is equal to 2x. 2 multiplied by x is equal to 2x. And 2 multiplied by 2 is equal to 4. So this will give us x squared plus 4x plus 4. Now we have expanded this binomial that is multiplying itself. But what if we have a situation where the equation is more complex? So instead of having x squared, let's say we have, instead of having a square here, we have, let's say, to the power of 7. So x plus 2 raised to the power 7 means x plus 2 is multiplying itself 7 times. If you are told to expand this, it will be very difficult to expand. So binomial theorem helps you to expand such equation easily. Okay, unlike when you are going to multiply this by itself 7 times, it's going to take you a long time to do that. Okay, so what we are going to learn today is how to use binomial theorem to expand binomials that are multiplying themselves. Okay, sorry, I'm a little bit distracted because I'm trying to check what is happening on TikTok, but I'm experiencing a little network issue there. So let's go further. Let's go further. So if I have a situation where I have a plus b squared, a plus b squared, a plus b, this is a binomial because it contains 2 terms, right? 2 terms. So this binomial is multiplying itself, a plus b squared. Now, it is very easy to expand this, okay? So we are going to expand it using the normal method of expansion. So this is going to give us a plus b into a plus b. So a times a will give us a squared, a times b will give us ab, b times a will give us ab, and b times b will give us b squared. AB plus AB will give us 2AB. So we have a squared plus 2AB plus b squared. So we have expanded this. Now, what if instead of having square here, we have cube? Let's see how we are going to expand it. So we are going to have a plus b cubed. So this means a plus b times a plus b times a plus b. So a plus b is multiplying itself 3 times. But we already know what a plus b times a plus b is because we have gotten it here. So this is going to be a squared plus 2ab plus b squared multiplied by a plus b. Because these two will give you this. So we can simply multiply this by this, right? So that means we have a squared times a will give us a cubed. A times 2ab will give us plus 2a squared b. A times b squared will give us plus ab squared, right? And then b times a squared will give us a squared b, ab squared. And b times b squared will give us b cubed. So I'm going to write it here plus b cubed. But let's bring like terms together. So if we bring like terms together, we have a cubed plus, we have 2a squared b, we have a squared b. This will give us 3a squared b. We have ab squared, we have 2ab squared. This will also give us 3ab squared. And then we'll have plus b cubed, right? So what we have done is we have expanded this to become this. What we are trying to do is we are trying to identify a pattern, okay? We are trying to identify a pattern because that pattern is going to help us with binomial theorem, okay? So what we are going to look at today is how the theorem is established. Then possibly in our next class, which is on Friday, same time, we are going to look at how to solve questions using Pascal's triangle. If we are fast enough, we are going to solve some examples today. Okay. So now when we have a plus b cubed, this is what we have when we expand it. So take note of this because we'll get back to it, and take note of this because we'll get back to it. So when we had a plus b squared, this is what we expanded. When we got a plus b cubed, this is what we expanded. So now we are going to look at a situation where this is to the power of 4. Where this is to the power of 4. Yeah, I can't give you my number on the live class, so you can send me a message right there on TikTok. After the live class, you can just send me a message and I'll send you my number. Okay, so let's look at a situation where we have a plus b to the power of 4. Let's look at that. Hope you've taken note of this. Let's continue. So a plus b to the power of 4 is equal to a plus b into a plus b into a plus b into a plus b. Because a plus b is multiplying itself 4 times. 4 times, right? But from what we did earlier, we already know this. We already know a plus b times a plus b times a plus b, because that is a plus b to the power of 3. So, and this is what we got. So this is the same thing as a to the power of 3 plus 3a squared b plus 3ab squared plus b cubed. Now we are multiplying it by a plus b. No, I can't pin my phone number here. No, I can't pin my phone number here. Sorry about that. Okay, so now we're going to multiply this by this. So let's try that out. I'm going to start from here. A multiplied by a to the power of 3 is going to give us a to the power of 4. A multiplied by 3a squared b is going to give us 3a cubed b. A multiplied by 3ab squared is going to give us 3a squared b squared. A multiplied by b cubed is going to give us ab cubed. So we are done with A. We go to B. B multiplied by a cubed is going to give us a cubed b plus b multiplied by 3a squared b is going to give us 3a squared b squared, right? Plus b multiplied by, where are we now? 3ab cubed. This is going to give us 3ab squared. This is going to give us 3ab cubed plus b multiplied by b cubed is going to give us b to the power of 4. Okay. So now let's bring like terms together. Let's bring like terms together. Send me a message here on WhatsApp. Send me a message on TikTok. Send me a message on TikTok, and then I'll give you my number. That's if I see that it's important for me to give you my number. Okay, so now let's bring like terms together. A to the power of 4. A to the power of 4. We have 3a cubed b. Where else do we have a cubed b? So we have a cubed b, a cubed b. So 3 plus this will give us 4. So we have 4a cubed b. So we've written this down, we've written this down, we've written this down. Here we have 3a squared b squared. Here we have 3a squared b squared. So we can write it down. So 3 plus 3 gives us 6. So we have 6a squared b squared. So we've written this down. We've written this down. Here we have ab cubed. Here we have 3ab cubed. So this will give us plus 4ab cubed. So we've written this down. We've written this down. And what is left is b to the power of 4. Okay. So that means when we have this is what the expanded form is. That's what the expanded form is. Okay, so we have written the expanded form for when a plus b is to the power of 2. We've written the expanded form for when a plus b is to the power of 3. We've written the expanded form when a plus b is to the power of 4. So this is guiding us to a particular point where we need to get to for today's class. Okay. So let's write down all we've gotten. Let's write down all we've gotten. Okay, I'm going to give you 2 minutes to write this down while I check my students on YouTube. Those of you on YouTube, do you have any question? Any question? Good evening, Aliyu. So let's continue. So we are looking at a plus b. We saw that when a plus b is to the power of 2, we had a squared plus ab plus b squared. Oh, sorry, 2ab. That's what we had. When a plus b was to the power of 3, we had a to the power of 3 plus 3a squared b plus 3ab squared plus b cubed. Okay, so this is what we had when a plus b was to the power of 3, right? And then when a plus b is to the power of 4, okay, our next class is on Friday, same time on Friday. So when a plus b is to the power of 4, what we had was a to the power of 4 plus 4a to the power of 3b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. Okay. So this is what we had for these three different situations. Now, what are we going to have if we have a plus b to the power of 1? A plus b to the power of 1 is simply a plus b. That's what it is. A plus b to the power of 1 is simply a plus b. And a plus b to the power of 0, a plus b to the power of 0, what will it give us? A plus b to the power of 0, anything to the power of 0 is equal to 1, right? Good. Anything to the power of 0 is equal to 1. So whenever you are expanding a binomial, as the exponent increases, the expansion becomes more complex. Whenever you are told to expand a binomial, as the exponent is increasing, the expansion process becomes more complex. But we can observe a trend here. Okay, we can observe a trend here. Sorry that I had to put 0 at the bottom, 1 here, but let's assume that 0 is at the top and 1 is next. Okay, so let's observe the trend. And what we are going to observe is the coefficient. We're going to observe the coefficients of what we have. Remember, the coefficients are the numbers in front of the variables. The coefficients are the numbers in front of the variable. So let's start with when our exponent is equal to 0. So when, where am I going to write this now? It might be a little bit small here. So when n is equal to 0, our coefficient here is 1. Please let me wipe this off. Let me write it here. A plus b to the power of 0 is equal to 1. Let me write it here. Okay. So when n is equal to 0, and remember n is the exponent here, our coefficient is equal to 1. So I'm going to put 1 here. When n is equal to 1, so here n is equal to 1. The coefficient of a here, who can tell us the coefficient of a here? Who can tell us the coefficient of a? From YouTube, who can tell us the coefficient of a? From YouTube, who can tell us the coefficient of a? What's the coefficient of a? Yeah. What's the coefficient of a? Somebody say 3. Coefficient of a here is 1, right? The number in front of a, since there's no number in front of a, we know that the number is an invisible 1. So the coefficient of a is 1. The coefficient of b, since there is no number, the coefficient of b is also 1. So when the exponent is 0, we have only one coefficient, which is 1. When n is equal to 1, we have two coefficients, and they are both 1, 1. So we go to when n is equal to 2. So when n is equal to 2, the coefficient of a squared here is 1. But let's start from here. The coefficient of AB is equal to 2. You can see 2 here. So we'll write it at the middle, 2. But the coefficient of A squared is 1. The coefficient of B squared is 1. Right? Let's go to when n is equal to 3. N is equal to 3. The coefficient of A cubed is 1. So write it down here. The coefficient of A squared B is 3. So write it down here. The coefficient of AB squared is 3. We'll write it down here. And the coefficient of B cubed is 1. So we'll write it down here. What we are trying to do is we are trying to establish a pattern that we can use to fill in more spaces. Okay? So what we are trying to do is we are trying to establish a pattern. Next, when n is equal to 4, when n is equal to 4, we have 1, 4, 6, 4, 1. So this will give us 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So what we did at the beginning was we expanded those binomials, and then we are using them to see a pattern that we can use for the binomial theorem. Okay? We are trying to establish a pattern. So now we've seen this triangle here. This looks like a triangle. If you draw it down, it looks like a triangle. Right? So this is called the Pascal's triangle. Now we can look at some things that we observe here. Okay, let me write the name down. The Pascal's triangle. So we have used this process to establish the Pascal's triangle. Now, remember, you can have n, which is the exponent, to be any number, but we just stopped at n equal to 4. You can have n is equal to 5, you can have n is equal to 6, you can have n is equal to 20 as far as possible. But now we stopped at 4 for now. Now let's look. Starting from the top, let's see how the pattern goes. We observe that all the numbers at this side are 1. So the numbers along these edges are always 1. Remember, these numbers represent the coefficients, not the exponents here, but the coefficients. So we observe that all the numbers here are 1. We also observe that all the numbers here are 1. Let's see how this is achieved. Let's see the pattern we can get here. Now, 1 here, 1, 1, but 2, without expanding manually here, we can see how to generate these other numbers. 1 plus 1 gives us 2. So we have taken note that the number outside is 1, the number outside is 1. So to get this number here, we simply add these two numbers on top to give us 2. We are generating a pattern. Okay? Next, we know that here the two numbers outside must be 1, but from the previous row, 2 plus 1 gives us 3. 2 plus 1 gives us 3. So we are going to have 3's here, and then we are going to have 1 outside. So we are establishing a pattern. And after we have established that pattern, I would like you to use this same pattern to tell me what what the numbers will be for n is equal to 5 without expanding manually. We are going to try to see if we can use this pattern to get what n is going to be for what the numbers will be for n is equal to 5, right? Okay, so now let's look at the next one. Here we have 4. How did we get these numbers? Without expanding here, how can we get these numbers? 3 plus 3 is equal to 6. 1 plus 1 is equal to 2. Sorry, 1 plus 3 is equal to 4. 3 plus 1 is equal to 4. So we've gotten these three numbers. Then the external numbers have to be 1. Okay? So, good. So somebody has tried out when n is equal to 5. Can some other person confirm it? What will the numbers be when n is equal to 5? What will the numbers be when n is equal to 5? What will the numbers be when n is equal to 5? Okay, some other person say 1, 5, 10, 5. Is that not going to, that's going to be incomplete. That's going to be incomplete. What's it going to be? Let me check those on YouTube. Okay, Omar said 1, 5, 10, 5, 1. 1, 5, 10, 5, 1. Okay, let's see. So I'm going to wipe this out. So without expanding manually, let's see what it will be when n is equal to 5. So first we are going to write down using these numbers we have here. We're going to combine them. 1 plus 4 is going to give us 5, right? We've gotten the first number. 4 plus 6 is going to give us 10. 6 plus 4 is going to give us 10. And then 4 plus 1 is going to give us 5. So these are the interior numbers gotten from the previous row. These are the interior numbers gotten from the previous row, but they must be enclosed by 1 on both sides. They must be enclosed by 1 on both sides. So observe it. 1 plus 4 gave us 5. 4 plus 6 gave us 10. 6 plus 4 gave us 10. 4 plus 1 gave us 5. But these numbers must be enclosed by 1 on both sides. Someone is asking, is that maths? Yes, it is mathematics here. Binomial theorem. Some other person is asking, what grade is this? I don't know. It depends on your country. I don't know what exactly. This class is for students from different countries. So depends on your curriculum in your particular country. So I might not be able to say this particular grade or this particular class. Yeah, you can do that research by yourself. If you're in Nigeria and you want to know about it, you can do your research for yourself. As I said, there are students from different countries. Okay, so now we are going to try to solve an example. We're going to try to expand a binomial using the Pascal's triangle. Okay, then we are going to confirm our answer by expanding it manually. We are going to try with something very easy. We'll start with something easy. Okay. So this first example, as I said, is very easy. You can just expand it easily, but we want to start with something easy before we go to something more complex. So expand x minus 2 to the power of 3. X minus 2 to the power of 3. So as I said, we're going to use Pascal's triangle to expand this, and then we're going to use the usual method of expansion to expand it, and then we'll check if we will arrive at the same answer. So first, let's use Pascal's triangle. So from Pascal's triangle, we know that we are trying to get used to the triangle. We know that we have 1, 1, 1, 2, 1, 1, 3, 3, 1, 1. Okay, remember we are looking at n to the power of 3. So this is n0, n1, n2, n3. So this is the one we are working with. That's why we are stopping here. Okay, so since n is to the power of 3, this is what we are working with. Okay, so remember these represent the coefficients. 1, 3, 3, 1 represent the coefficients. So we're going to use this to expand this. Ready? So first of all, we are going to assume that these two terms, remember these are terms, term 1, term 2, they are each going to become x to the power of 3 minus 2 to the power of 3. For example, sorry, this is to the power of 3. Okay, we're going to assume that. But as we move from left to right, we are going to ensure that the maximum exponent is going to be 3. Here, if you look at it, you have 3 plus 3, this is 6. So we are going to move from x is going to have the maximum exponent, and this is going to have 0. So it's going to be x to the power of 3, and minus 2 is going to have 0 as the exponent. Okay? So as we move from left to right, the exponent of x is going to be decreasing, while the exponent of minus 2 is going to be increasing. Okay? So the exponent of x is going to be decreasing, while the exponent of minus 2 is going to be increasing. So we pick the first coefficient, which is 1. So this is going to be 1 times x to the power of 3 times minus 2 to the power of 0. I like us to do it carefully. So this is, we have picked this one. For this one, x to the power of 3, x has the maximum exponent, while minus 2 has an exponent of 0. Then we go to this one, so we have plus 3 into, as we are moving this way, the exponent of x is reducing, so we have x to the power of 2 minus 1, minus 2 is going to have an exponent of 1. So the exponent of x is reducing, the exponent of minus 2 is increasing. Next, we go to this plus 3 into the exponent of x is going to reduce more. So x to the power of 1 minus 2 into 2 to the power of 2. So at all times, when you sum the two exponents, they must give you 3. When you sum the two exponents at all times, they must give you 3. And then we'll go to the last one. Plus 1 into x to the power of 0. It has dropped from 1 to 0. And minus 2 to the power of 3. So at this point, minus 2 has the maximum exponent, while x has an exponent of 0. So we know that anything raised to the power of 0 is 1. So that means minus 2 to the power of 0 is 1. So we can simply say 1 times x to the power of 3. And that will give you x to the power of 3. So we have simplified this, right? And then we have here minus 2 to the power of 1 is minus 2. Minus 2 times 3 is minus 6. Hope you guys are following. Minus 2 to the power of 1 is minus 2. And minus 2 times 3 is minus 6. So we have minus 6 x to the power of 2. We go over here. Minus 2 to the power of 2 is 4. Minus 2 to the power of 2 is equal to positive 4. Someone was asking me on YouTube, are you Indian? No, I'm not Indian. I'm Nigerian. I'm Nigerian. Okay, so minus 2 to the power of 2 is equal to 4. 4 times 3 is equal to 12. So x to the power of 1 is the same thing as x. So we have plus 12x. And here, x to the power of 0 is equal to 1. Minus 2 to the power of 3 is minus 8. Minus 2 to the power of 3 is minus 8. Hope you guys agree with that. Minus 2 to the power of 3 is minus 8. Hope you guys agree with that. So minus 8 times 1. Remember, x to the power of 0 is 1. So we have 1 times minus 8, and that will give us minus 8. And with this, we have expanded this binomial using Pascal's triangle. We have expanded it using Pascal's triangle. My YouTube channel is Agbani Maths Academy. The same name I have on TikTok, that's the same name. The same name. You can check out all the live classes I've had previously on the playlist of my YouTube channel. If you go to the playlist of my YouTube channel, you're going to see all the live classes I've had. I saved them there. Okay, so somebody says he or she did not understand. So I don't know if you were here when we looked at the Pascal's triangle. So we are going to start from there. I'm going to assume that you were here. Someone said, how did you get minus 8? Minus 2 to the power of 3. Minus 2 multiplied by minus 2 is going to give you positive 4. Positive 4 multiplied by minus 2 is going to give you minus 8. Because minus 2 is multiplying itself 3 times. Minus 2 times minus 2 times minus 2. This is going to give you positive 4. When positive 4 multiplied minus 2 is going to give you minus 8. Minus 8. So that's how we got minus 8. Then minus 8 times 1 is going to give you minus 8. Remember, x to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. Someone has asked that question before. This is for what class? I don't know specifically, but I know it's in Nigeria is basically for senior secondary school 3, SS3, I think. Yeah, SS3. I don't know about other countries. Okay. So we've used the Pascal's triangle to expand this. Remember, in the Pascal's triangle, first you need to locate what exponent you're working with. That determines the values you're going to use to expand. So we are working with an exponent of 3. So this is exponent of 0, exponent of 1, exponent of 2, exponent of 3. We don't need to go further to exponent of 4, 5, 6, 7, because we are going to be making use of this row. In this row, we have 1, 3, 3, 1. So we are going to use these numbers to expand this. So we pick 1, here we have 1, and then x to the power of 3. This, the exponent there, we are going to give it to the first term. And then the second term, we have no exponent, 0 exponent, because the sum of the two exponents must be the same as 3. So 3 plus 0 is 3. So, but as we move towards the right, the first term will be losing one exponent for each subsequent term, while the second one will be gaining an exponent. So x is losing an exponent as we go towards the right, while minus 2 is gaining an exponent as we go towards the right. So here we have x to the power of 3 minus 2 to the power of 0, x to the power of 2 minus 2 to the power of 1, x to the power of 1 minus 2 to the power of 2, x to the power of 0 minus 2 to the power of 3. So while x is losing exponent, minus 2 is gaining exponent. Okay? So next, you simply expand this. We know that minus 2 to the power of 0 is 1. So x to the power of 3 times 1 will give you x to the power of 3. Minus 2 to the power of 1 is minus 2. Minus 2 times 3 is minus 6. We have x to the power of 2. Minus 2 to the power of 2 is positive 4. Positive 4 times 3 is 12. X to the power of 1 is the same thing as x. And then we have minus 2 to the power of 3 is minus 8. X to the power of 0 is 1. So 1 times minus 8 gives us minus 8. So we have used Pascal's triangle to expand this simple binomial. Okay? So now let's see if our answer is correct by going through the normal way of expansion. Let's see if we're going to arrive at this. Let's try it out. So x minus 2 to the power of 3 is something like x minus 2 into x minus 2 into x minus 2, right? So when we multiply these three, let's see if we're going to arrive at this. So x times x, let's work on these two first. X times x gives us x squared. X times minus 2 gives us minus 2x. Minus 2 times x gives us minus 2x. Minus 2 times minus 2 gives us plus 4. So we have, if we bring these two together, minus 2x minus 2x gives us minus 4x. So we're going to have x squared minus 4x plus 4. This is one bracket, and it's going to multiply this because we are bringing it down. X minus 2. Okay? So now we use this to multiply this. X multiplied by x gives us x squared. X multiplied by x squared gives us x cubed. X multiplied by minus 4x gives us minus 4x squared. X multiplied by plus 4 gives us plus 4x. We are done with x. We go to minus 2. Minus 2 times x squared gives us minus 2x squared. minus 2 times minus 4x gives us plus 8x. Minus 2 times plus 4 gives us minus 8. Right? Okay. So let's simplify this. We have x cubed minus 4x squared minus 2x squared gives us minus 6x squared. Plus 4x plus 8x gives us plus 12x. And then we have minus 8. Okay? Now, you might not see the value of using Pascal's triangle because this looks simpler than what we did when we went through Pascal's triangle. But when you now have exponents that are very large, then you see the benefit of using Pascal's triangle. Yeah, I know. That's why I was saying that this looks easy. I know you guys will prefer this method. It looks easy when the exponent is small. But what about a situation where you have an exponent of 7, 8, 9? Then you have to do this thing 8 times or 9 times or 10 times. So you multiply them, it takes very long. That is where Pascal's triangle makes the work easy. Okay? We've almost exhausted the time we have. For those of you that are on TikTok, I don't know if it's going to be the same way, but most times once I am on TikTok for 1 hour, the live session is going to end automatically. So if it ends any moment soon, please, you can just check back. You can follow me right away so that once I come back live in a few seconds, you'll be notified that I'm back live. Okay. So let's see if we can do something a little bit more complex. Not complex, a little bit more complex. Just a little bit more complex. So let's wipe this out. Hope I can wipe this out. Oh, sorry, on YouTube, someone says, where did x to the power of 3 minus 2? Oh, so sorry, I didn't see that message early enough. Sylvester on YouTube, sorry. Sorry, I didn't see that message early enough. In my next class, I'm going to get my second phone, so I'll be able to view your comments from both platforms at the same time. So for now, what I'm doing is I move from one platform to the other. So sorry that Habiba, sorry that I didn't answer your questions. So sorry. Okay, so let's. Thank you also, Kalistu. Thank you so much. So let's look at the next example. So this will be the last example for today. Yeah, somebody said he preferred the other method. So I would like to see if you will still prefer the other method as we get to solve more complex questions. Okay, so we are using Pascal's triangle to solve this. We are using Pascal's triangle. So the first thing we need to do is remember n is 4. So we have, this is when n is equal to 0. This is when n is equal to 1. This is when n is equal to 2. This is when n is equal to 3. And then this is when n is equal to 4. So over here, n is equal to 1. Sorry, n is equal to 0. n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. So our exponent here is 4. So this is the one we are working with. That's the one we are working with. So that means we are going to expand this following this arrangement, right? So we're going to see when the coefficient is 1, when the coefficient is 4, when the coefficient is 6, when the coefficient is 4, when the coefficient is 1. Remember also that the exponent of 2x starts from the maximum and decrease, while the exponent of 3y starts from the minimum and increase, just as we did. Oh, I think you say, someone said, how did you know the arrangement? We have already looked at that earlier on in today's class. So if you missed that, you can watch the replay on my YouTube channel at Binomials Academy. The same name I have on TikTok, that's the same name on YouTube. So you can go to the playlist section of my YouTube channel. You're going to see all the videos, all the live classes I've done previously, and also today's class. So we've learned about how to arrange this. Okay, we've learned about that. So I might not be able to go back to that. But so now we are using this because our exponent is 4. So we are using this. So this shows our coefficient. So let's start. Our coefficient is 1. So pick 2x. 2x. 2x, the exponent of 2x is going to be maximum, while the exponent of 3y is going to be minimum. So the maximum exponent is 4. So the exponent of 2x is going to be 4, while the exponent of 3y is going to be 0, from what we've learned before. Okay? Then we go to this part where our coefficient is 4. So plus 4. What will be the coefficient? What will be the exponent of 3x at this point? What will be the coefficient of 2x at this point? Opeyemi said 3. Okay, the exponent of 2x is going to be 3 because the exponent of 2x is dropping, so it's going to be 2x to the power of 3. The exponent of 3y is increasing, so it's going to be 3y to the power of 1. So we are done with this. We go to this one, plus coefficient of 6. The exponent of 2x is still decreasing. It's going to be 2. So 2x to the power of 2 into 3y. Its coefficient is increasing. So it's going to be 3y to the power of 2. Good. Very good. Very good. So we are done with this. We go to this. Plus 4 into the coefficient of 2x is dropping, so we have 2x exponent of 1, and then 3y exponent of 3, plus we go to the last one, 1 into 2x exponent of 0, 3y exponent of 4. So that's all we need to do. The next thing we need to do is just expand this. 3y to the power of 0 is equal to 1. So this is equal to 1. But now, laws of indices comes into play. This exponent of 4 belongs to both 2 and x. The exponent of 4, since there's a bracket, does not only belong to x, it belongs to both 2 and x. So this is going to be 2 to the power of 4. What's 2 to the power of 4? What's 2 to the power of 4? What's 2 to the power of 4? 16. Okay, 16. So 2 to the power of 4 is 16. 16 multiplied by 1 is going to give you 16. So we have 16. X to the power of 4 is, we have x to the power of 4, right? Plus this exponent here belongs to 2. This exponent belongs to x. This exponent belongs to 3. This exponent belongs to y. So 2 to the power of 3 is 8. 3 to the power of 1 is 3. So we're going to have 8 times 3, then times 4. Hope you understand that. This 4 is this 4 here. 2 to the power of 3 gives us 8. 3 to the power of 1 gives us 3. So sorry, those of you on YouTube, just give me a minute. I have an issue with TikTok. Okay. Okay, so continuing with the class, we have 4 times 8 times 3. 4 times 8 is 32, right? 32 times 4 times 8 times 3. What's it going to give us? Who can tell me on YouTube? Who can tell me? 4 times 8 times 3. 4 times 8 times 3. This 4. 2 to the power of 3 is 8. And then 3 to the power of 1 is 3. I didn't end the live. I said earlier that once it gets to 1 hour, TikTok is going to end the live automatically. So 4 times 8, 32. 32 times 3. What's 32 times 3? What's 32 times 3? What's 32 times 3? I think we are now experiencing some network issue. Yeah, good evening. Yeah, it seems that there's a network issue. If you are struggling with the network, then you can just go to my YouTube channel and continue there. Sorry, I don't know why the network suddenly became bad. So let's continue. So 4 times 8 is 32. 32 times 3 is 96. So we have 96. And then x to the power of 3. And then y to the power of 1. So we have y. So we are done with this. We go over here. 2 to the power of 2 is 4. 3 to the power of 2 is 9. So we have 6 times 4 times 9. What's 6 times 4 times 9? What's 6 times 4 times 9? Please, if you are struggling with the network on TikTok, you can switch over to YouTube. You can just search for my YouTube channel, Binomials Academy on YouTube. Uh, the live class is going on there also. So 6 times 4 times 9, what do you have? 6. Okay, 4. 2 to the power of 3 is 2 times 2 times 2, which is 8. 3 to the power of 1 is 3. So 4 times 8 times 3. What's 4 times 8 times 3? Okay. Okay, I think I should just be continuing with the class on YouTube. So you can join us on YouTube. I'll leave the live class on TikTok, but you can just switch over to YouTube. So 4 times 8 times 3 gave us 69. X to the power of 3 gives us x to the power of 3. Y to the power of 1 is the same thing as y. So we moved over here. 6, we have 6. 2 to the power of 2 is 4. 3 to the power of 2 is 9. So 6 times 4 is 24. 24 times 9, what do you have? 24 times 9, 116. So we have 216. 216 x squared plus y, x squared, y squared. So we are done with these ones. We go here. So 2 to the power of 1 is 2. 3 to the power of 3 is 27. That means we have 4 times 2 times 27. 4 times 2 times 27, what are we going to get? 4 times 2 times 27. What are we going to get? Okay, the network is good now. So 4 times 2 times 27. Where are we now? 4 times 2 times 27. 3 to the power of 3 is 27. 2 to the power of 1 is 2. So we have 4 times 2 times 27. What do we have? That will give us 236. 236. So this will give us plus 236. X is to the power of 1. So we have x. Y is to the power of 3. So we have y to the power of 3. Sorry, let me rewrite this. I think it has gone too far here. Let me rewrite it. So plus 236 x y to the power of 3. Okay. So we are done with this. So we go over here. Plus 2 to the power of 0. 2x to the power of 0 is going to give you 1, right? So everything here is equal to 1. So 3 to the power of 4. What's 3 to the power of 4? What's 3 to the power of 4? plus 3 to the power of 4. Someone is still saying the network is bad. 81. Please, if the network is bad, you can switch over to YouTube with the same name. With the YouTube platform has the same name, Binomials Academy. 81. So we have 1 times 3 to the power of 4. 3 to the power of 4 is 81. So 81 times 1 will give us 81. And then we have y to the power of 4. And with this, we have expanded this using the Pascal's triangle. So we have expanded it using the Pascal's triangle. It's quite easy. It's quite easy. We've spent so much time today. So what I'm just going to do is I'm just going to give you one question to try out, and then we're going to have a class again on Friday, 8 p.m. Nigerian time. 8 p.m. Nigerian time. You can also join my WhatsApp group by sending me a message on TikTok, or going to my bio, click the link on my bio, and you see the option to join my WhatsApp group. So you can join my WhatsApp group. And then also you can follow me on Facebook. I don't do Instagram. You can follow me on Facebook. I'm going to leave the link to follow me on Facebook at the end of this live class. So let me write down the assignment for today that you can try out. If you want to watch the replay, maybe you joined the class late and you want to watch the replay, you can go to my YouTube channel, Binomials Academy. Check out the playlist session, and you see all the classes that we've done before today, and also today's live class. You see everything there. You can also share it with your classmates, share it with your friends, those who are struggling with any topic in mathematics. Sorry about the network issue. I don't know why it just suddenly happened like that. So the assignment for today really? Did I make a mistake? Oh, and I've even wiped it off. I'm going to check it again to see if there was any mistake. So this is the assignment for today. So try it out and then join me again on. I was really distracted towards the end of the class because of the network issues. So I was really distracted. Sorry about that. So try out this question and then join me again on Friday, same time, on TikTok and on YouTube. So those of you on YouTube, I'd like you guys to try this question. Try this question. Were we multiplying by 2? Okay, 4 times 2 times 27. Okay, thank you. Thank you so much. 216 instead of 236. Okay, thank you so much. Thank you. So we continue on Friday, same time. Have a wonderful evening. Enjoy the rest of the night. Bye.